In this video, we will be talking about complex numbers. We'll talk about complex numbers. Complex numbers are numbers that can be written in the form a plus bi, where this I is the imaginary unit. Let's begin with a definition. I is the square root of -1. Previously, we've dealt only with real numbers. Now we're entering complex numbers, and what separates the two is this particular number. All this number is going to allow us to do is handle square roots of negatives. Previously, we've said we cannot take the square root of a negative number, and that is indeed true for our real number system. But now that we have this I being the square root of -1, we will be able to handle it. So when we have any square root, we're simply going to, any square root that involves a negative, we're simply going to introduce this value I. Alright, couple properties. I squared is going to equal -1. And I know what you're thinking right now, well, isn't a negative times a negative a positive? Well, square root of -1 is not a negative number. We're defining it as just I. And this makes sense because when we multiply a square root by itself, that number comes out. That is, the radicand is what it's going to be equal to. Alright. I to the third power? Well, I to the third power, using our rules of exponents, is the same as I squared times I to the first. Again, if our base is the same, we simply add together the exponents. 2 and 1 in this case is 3. So we know that I to the third is the same as I squared times I to the first. Well, we've just said that I squared was -1, and I to the first, well, that's just I. So -1 times I is a negative I. Alright. Well, I to the fourth, by the same reasoning, I to the fourth would be I squared times I squared. And I squared is -1, so what we have is -1 times -1, and that's 1. Well, what you can see from now is this thing will be cyclical. I to the fourth is equal to 1. I to the fifth will be equal to I. I to the fifth will be equal to I. And I to the sixth will be the same as I squared. Why? Well, because I to the sixth is I to the fourth times I squared. And we just found out that I to the fourth was 1, so this I to the fourth is 1. And I squared is I squared. So you can see that I to the sixth will be equal to I squared. Alright, so to find any power of I, we can simply write it as a product of any of these. That is, we'll just keep this cycle in mind. Okay, so what sort of operations we're going to or we will have to do? What kinds of operations will we need to perform? Alright. So one thing we're going to have to do is to simplify powers of I. Let's just say, so example, simplify powers of I. Let's say they ask us to simplify I to the 30th. Well, we are simply going to realize that this little cycle is going to hold. Okay, the first out of the first is square root of negative 1, out of the second is negative 1, out of the third is negative I, out of the fourth is I. So essentially, I'm going to write this I to the 30th as some product that's going to be these 4s and 2s. So, well, out of the 30th is I to the 28th times I squared, because 28 and 2 is 30. Why did I choose I to the 28th? Because 4 will go into that, and I know that I to the 4th is equal to 1. So now, I to the 28th I can write as I to the 4th to the 7th power. That is our power property of exponents, because 4 times 7 is 28. I still have my I squared here. Well, we know I to the 4th is 1. So I to the 4th becomes 1. We have 1 to the 7th. Well, 1 to anything is just 1. Well, 1 to anything is 1, so this cancels. And we know I squared from previous I squared is negative 1. So this is 1. And I squared is negative 1. Thus, I to the 30th is negative 1. So we can take any power of I and get it back to one of these original 4, either the square root of negative 1, negative I, or 1. One more example. Let's take an odd power like I to the 11th. Well, I will begin and write it as a power of 4 or a power of 2 times something. So in this case, I to the 11th I can think of as I to the 10th times I. I'm going to write 1 here. We don't need to write that 1, just so you can see that 10 plus 1 is 11. Why did I write it as I to the 10th? Well, I know from previous that I squared is negative 1. Alright, so if I can write it as any power, any even power, whether it's divisible by 4 or simply divisible by 2, that will be very useful. So this I10 now can become I squared to the 5th, because 2 times 5 is 10. We still have our I over here. Well, we know from earlier I squared is negative 1, so what we have here is negative 1 to the power of 5. Negative 1 to the power of 5 is negative 1. Thus, negative 1 times I is negative I. Alright, those are 2 examples of simplifying powers of I. We simply take our whatever our power is and write it as a product of powers, and let one of those be divisible by 4 or divisible by 2, and then we can quickly get this 1 or negative 1 substitution. Alright. How about when we are adding or subtracting? Add or subtract complex numbers. Well, it's going to be a matter of combining like terms. For instance, if I have the complex number 4 plus 3i, and I'm adding to that the complex number 2 minus 7i, we are simply going to combine essentially our like terms. The real term can add together. 4 plus 2 will give 6, and the imaginary part will add together. 3 minus 7 is minus 4i. Alright, subtracting complex numbers. So let's say we have 5 plus 2i, and we're subtracting 9 negative 3 plus 8i. Well, just as before, when we have this negative, we distributed, that is, we changed the signs in the parentheses behind, we will do similarly. I'll begin by dropping my parentheses. Minus a negative becomes plus 3. Minus plus 8i becomes minus 8i. So again, we will combine our like terms. 5 and 3 combined to give 8. Plus 2i and minus 8i combined to be minus 6i. And in either of these cases, we cannot simplify any further. We cannot combine our real part with our imaginary part. And we call this the imaginary number. It's a rather unfortunate name. There's nothing imaginary about it. It is simply a way for us to handle this square root of a negative. I is the square root of negative 1. Okay. Now we'll lastly look at multiplying rational numbers, multiplying complex numbers. Okay. You saw with the adding and subtracting, essentially we treated I like it was some variable, x, m, whatever it might be. We combined our, added or subtracted our real parts, we combined our imaginary parts, and we had some complex number, a real part plus or minus an imaginary part. Well, we will treat the multiplying the same way. So let's say we have the imaginary number 4 plus 7i, the complex number 4 plus 7i, and we are multiplying times 3 plus 5i. Alright. Just as before, using the distributive property, we will take this number here and multiply by both numbers in the connected parentheses. So 4 times 3, that's 12. 4 times plus 5i, that will be 20i. Now we will distribute the 7i. 7i times 3 is a plus 21i. And 7i times 5i will be a plus 35i squared. Well, you can hopefully see that these two are like terms and we should combine them. So we have 12 plus 41i, and then we have this 35i squared. Well, we know I squared from earlier is negative 1, so this becomes plus 35 times negative 1. I squared is equal to negative 1. Well, 35 times negative 1 is negative 35, so this negative 35 will sum with 12 to give a negative 23. So our final answer here is negative 23 plus 41i. 12 and negative 35 is negative 43. With this information, you should be able to handle the problems from the complex number assignment.